All right, so let's take a minute here to consider another very important aspect of polynomial functions. And what we're really interested in this chapter in finding polynomial functions is being able to find where the zero is. Thus, if we want to find the values of x equals c, we're looking for values where the function evaluated x equals c is equal to 0, or, to put another way, finding out where the x-intercept is, or, put another way yet, is that x equals c is a solution to the function f of x equals 0. So how do we actually go about that? Well, one way of us doing that is something called the intermediate value theorem. And the intermediate value theorem is very interesting in that it states something that might seem like it's obvious. It's an existence theorem. That's it. An existence theorem is a kind of rule in algebra that just tells us when something is going to happen. It doesn't tell us how to find it or where to find it, just that it can happen. This particular theorem says that if we have a polynomial function p of x, and the polynomial function is such that if we pick two values for x, a and b, and evaluate the function at a and evaluate the function of b, and we find that the value of p of a does not equal the value of p of b, then p takes on, the y value takes on every value between p of a and p of b. And you're probably scratching your head and going, okay, Professor Peoples, real good. So, well, there's a very big implication right here, and this is one that's really useful for us. It says that if we have a function where we evaluate p of x at x equals a, we find a negative value. And then we evaluate the function p of x at x equals b and find that the y value is positive. What must happen? Well, if a is to the left of b, then on the graph of p of x, there must be a 0 somewhere between a and b. That is, if I were to draw my graph of the function of this polynomial, pick 2 points a and b along the x-axis, I find that the value of y at x equals a is below the x-axis, it's negative, and the value of y above the x-axis at x equals b. Since polynomials are all smooth, continuous curves, that is, the kind of curves that I could draw by putting my pen down on the paper and then not having to pick up my pen from the paper, just connect the dots, the only conclusion that we can reach is that this function must pass through the graph at 0 somewhere in there. That is the implication of the intermediate value theorem. So as an example, how would we use it? Well, let's say we're told to use the intermediate value theorem to verify that p of x equals x to the fourth minus 4x cubed minus 2x squared plus 8 plus x minus 8 has a 0 somewhere between 4 and 5. What does that mean to us? Well, let's go through it. If we remember from our synthetic division that we can use the remainder theorem to evaluate a function like p of x at x equals 4 and x equals 5, then to find p of 4, we'll go ahead and use our synthetic division to work it through. So let's put in 4 here for x. Let's put our coefficients 1, negative 4, negative 2, 1, and negative 8, and let's work out what we get for p of 4. Well, bring down the 1. 4 times 1 is 4. Add, we get 0. Multiply 4 times 0. Add, going down the column to get negative 2. 4 times negative 2 is negative 8. Add negative 8 to 1, you get negative 7. And 4 times negative 7 is negative 28. So we get as a y value negative 36. So p of 4 is equal to negative 36. How about p of 5? Well, let's do the same trick. What happens if we put in 5? At x equals 5, as a result of our synthetic division, coefficients 1, negative 4, negative 2, 1, and negative 8, bring down the 1. Multiply 5 times 1. Add, going down the column, 5 and negative 4 is positive 1. 5 times 1 is 5. Add going down the column, 5 minus 2 is 3. 5 times 3 is 15. Add going down the column, 15 plus 1 is 16. 5 times 16 is 80, and 80 added to negative 8 is 72. So P of 5 is equal to 72. The result is that by the intermediate value theorem, since P of 4 is negative and P of 5 is 72, we must conclude that a 0 exists somewhere between x equals 4 and x equals 5. Now, if we were to actually go through and verify what our graph looks like, here's what we might see. The graph appears to show that on the interval from 4 to 5, so from x equals 4 to x equals 5, which is somewhere way up here, we find that the graph must pass through 0, somewhere here. So there is a 0 along this graph somewhere in this vicinity from 4 to 5. Now, we're not told exactly where that is. We would have to do a lot more work to actually find that coordinate point, but based on the intermediate value theorem, a 0 does exist between those points. And that's what we're looking for here. Okay, more in the next video.